Well, guys, for a change of pace here, I decided that I'd actually do some work, during my plan period instead of just laying around taking a nap or checking Facebook. So let's get to it. Okay, we're going to do a lesson on parent functions and transformations today. It's going to be pretty important that I'm going to throw a lot of stuff at you today, and it's really important to take good notes because, again, when we're working on the homework tomorrow, you're going to want to make sure that you have those notes because, again, it's not going to like that. All of this stuff is not going to get in your head until you you really practice it and you really start trying to memorize it. So anyway, let's go ahead and get to it. Vocabulary, you guys probably want to write down. These are all the different types. The first four are the types of functions you're going to deal with, and the bottom two are going to be what we're going to be kind of doing, how the graphs are going to be changing. And again, there's really not a whole lot. You guys, these we'll define these. The only thing I will point out too is that a horizontal, something like that, vertical. You guys should know. I think NBA basketball players, they jump up and down. They got a big vertical. And then reflection, pretty straightforward. Again, that's just going to be something that is like if I gave you this graph here. Okay, instead it would be the reflection of it would be like this over the x-axis or something like that. And we learned in the last video that the absolute value was a V shape, something like that. And again, this right here is a quadratic, again a parabola, a U shape. The identity function is actually a line, looks something like that. And the constant function is also a line, but it's just a horizontal line, just like that. Alright, so again, let's start with the constant function. Again, this is going to be in the form f of x equals c. Again, in your notes while you guys are doing these, make sure you are just kind of sketching each one. So again, it's going to equal some, like f of x, the function is going to equal some constant number. It really doesn't matter what it is because it's always going to be the same. Remember that f of x is the same thing as y. So again, I could rewrite this, like if I said f of x equals 2, I could rewrite it as y equals 2, which would be just this horizontal line right here, except straight. I can't draw a straight line. There you go. Something like that, but better. Alright, now again, this is the constant function. Now again, if you talk about the domain, is always x, so you see that it goes on and on forever this way, and on forever this way. So the domain is going to be negative infinity to positive infinity, or all real numbers, however you want to say it. And then the range is actually just going to be one number. You see on the y, it doesn't go up or down. It's not going anywhere. So the range is actually just going to be 2. Not too bad. All right, that's the constant function. Identity function is f of x equals x. Again, this is going to be the same thing as y equals x. So just a line, again with a slope of 1 and the y-intercept at 0. So start at 0, go up 1 and over 1. Go down 1 and over 1 as well, and here you go, something like that, except better because I can't draw a straight line. Again, domain in this case is actually going to be the same because you see it goes on and on forever and on forever to the right as well. So negative infinity to positive infinity, and then the range is actually the same deal. It's going on and on forever to positive infinity up and then on down. So we'll do the same thing here. Negative infinity to positive infinity. Alright, that's the identity function, not too bad. Okay, absolute value. We already talked about this, but again, it's worth noting, worth just going over again, so I'm just going to go over real fast again. You know that the absolute value function right here, this is the parent graph of that. It has a slope of 1, so start in it, the vertex is 0. So you go up 1 over 1, and then up 1 and over 1 the other way. Man, that's bad. I can do better. Maybe. Nah, we're getting there. Things to work on for Mr. Shaw. And then the domain, as we discussed yesterday, again, you see each way on the x-axis it's going on and on forever. So it'll be negative infinity to positive infinity. And then the range, it stops at 0, so it's going to be inclusive at 0, comma, infinity. Next one. We've got the quadratic function. Alright, so this one's going to be really important. Again, we're going to see this a lot. So like I said, I want to I'm going to make a quick chart here of an XY chart just to graph it. So again, I've got, if I use negative 2, negative 1, 0, 1, and 2, that was a terrible 2. 1 and 2. Again, if you plug it in, -2 squared is 4, -1 squared is 1, 0 squared is 0, and then 1, and then 4 again. So if I plug that in, 2 comma 4, and -2 comma 4, I can do better. There we go. All right, so we got a little U shape here. Again, it's not a V. Not a V. Okay, you want to have a nice, curved edge right here. This is your parent graph. Okay, again, f of x equals x squared. So the domain again is going on and on forever, negative infinity to positive infinity, and the range will actually be exactly the same as the absolute value. So inclusive on 0 all the way to infinity. This one's really important, guys. Make sure you put a fierce star by it. Alright, so again, we're going to identify. Again, those are all the ones we need to know for now. We're going to just work on identifying here. Again, you can see that this is not a V. Okay, it's not a parabola. So okay, this is going to be a quadratic. Again, B is a line, so you can just write linear. I'm sorry. It's linear, but again, and again, if you want to talk about the type of function, it really wouldn't fit into identity. But again, you just need to be able to be aware that you need to be able to identify it as a line and as a linear function. Okay, next one. Okay, here we go. This will fit into the constant function. Okay, so this one is constant right here. Again, I'll write constant / linear. And I want to identify this one too. Okay, again, f of x equals, you see it's at -3, so f of x equals -3. And the last one, you see that this is a v, so that is going to be absolute value. Alright, 2 more. Oh, no, I lied to you. Never mind. Okay, sorry. We're going to go into translations and transformations. Okay, this is where we're actually going to start moving stuff around. Okay, again, like I said, translations or transformations, just moving a graph up or down and moving it left and right is called translation, or you can also call it transformation. You'll probably hear me say transformation more than translation, but just know that these words are the same. They mean the exact same thing in math. Alright, go ahead and write that down when you get it, and pause the video and write these down, guys, because again, I'm going to kind of go a little bit faster here. Again, vertical translations, what you're going to see, again, it's whenever you're moving the graph just up and down. So what you're trying to pay attention to, so you're going to have a function, okay, and there's going to be some outside number, plus k or minus k. Okay, so now again, it's like, so for example, if I gave you a quadratic function that was like x, let's rewrite it, x squared minus 4. Okay, again, you're going to see, okay, here's my function, and I'm going to take it, I'm going to move it down 4 units, and that's it. Okay, again, if there's something on the outside, hey, like I could write it as the absolute value of x minus 4. Again, this would be taking the parent graph, the absolute value, and moving it down 4 units. All right, now we got a horizontal next. Remember in math that inside is always opposite, and that the same is true here. So again, you see if you have f of x plus h, it's going to move left, and minus h is going to move it right, which is counterintuitive when you're thinking of the x-axis. Okay, so again, remember that inside is always opposite. So again, if I have something like, let's say I had the absolute value of x minus 3, and I wanted to graph it. Okay, so again, here's my graph. I'd have to go 3 units again, but since it's minus, I'm going to move to the right. So 3 units to the right, 1, 2, 3, and that could draw my absolute value graph right there. Okay, so again, remember that inside is always opposite, and again, make a note, put a star, because it is important. All right, let's get into it. All right, so again, you see here, we're just gonna start by describing it, then we're gonna graph it. So you guys know that the parent function is this. So 1, 2, 3, 4. Okay, that's the parent graph of this right here. Then blue is y equals x squared. Okay, in red, I'm gonna do this guy. So you see here we got an inside number, so that means it's going to be a horizontal shift. So it's plus 1, but again, it's always opposite. So I'm going to say horizontal shift, and we're going to go left 1. Okay, that's the important part. So we're going to move it 1 unit over. Okay, but everything else is going to stay the same. You just move all of our points 1 over, and then we'll be good. We can just go ahead and grab it from there, just like that. So the red is our answer. Okay, again, the blue is just the parent graph that I did in the dots, and the red is the answer because I just shifted left 1 unit. And I'll say 1 unit. I should let's be thorough here. All right, keep going. Absolute value of x minus. Oh, look at that! We literally just talked about this one. Okay, so again, the absolute value of x. I'll do it in red. So here's the parent graph. Absolute value of x, which would look like this. Okay, and now again in blue, I will do the translation of the transformation. So again, I'm going to take this whole graph. This is outside the parentheses, and again, outside never changes. Whatever you see is what you get. So this is -4, so we're going to go down 4 units. So I'm going to say vertical shift down 4 units. All right, so we'll go down 1, 2, 3, 4. I messed up there. Hang on. Sorry. Couldn't tell. Alright, there we go. There we go. That's better. So this will be our answer. Okay, keep going. Now we're going to add both. Okay, so again, remember that the parent graph here, again, you see the square, it's going to be quadratic, so y equals x squared. And I'll go ahead and just draw the parent dots real fast. Again, you guys will get better at it as you see it more often. No, I don't want to draw that. Sorry. There we go. Okay, I'm just going to leave it as dots. And I'll do this in red. So again, you see here I've got, let's do I'm going to say H shift. Okay, the horizontal shift is going to be inside. Remember, inside is opposite, so it's actually going to be going to the right 2 units. And then the vertical shift is going to be, okay, so down 4, or -4, so that means it's going to go down 4 units. Alright, so again, I'm going to take, basically you can just take each dot and move it that way. So again, we're going to go right 2 and down 4. 1, 2, 3, 4. And fill everything else in. Alright, and here will be our answer. Okay, keep going. Got a few more things. Again, I wanted to show you these just because, again, we don't have a whole lot of time left. I want to show you reflections as well. But in your book, whenever you get something like this, just make sure you're looking for the vertex. Remember that the vertex of parent functions are always at 0. So in this case, what you do is you're going to go over 2 units. Okay, so the inside, again, it would be just like f of x equals. Inside, it'll be x. Again, we're going left, so it's going to be plus 2 units squared, because it's a parabola, it's quadratic. And then we're going down 3, so on the outside it'll be -3. And you can just say left 2 and down 3 units. Alright, let's go to reflections. Okay, go ahead and pause the video, and I want you guys to write this down. Again, a reflection flips a figure over a line, and that's going to be called the line of symmetry or the line of reflection. Important point is that if you have a negative on the outside of your function, it's going to flip it over the x-axis, and a negative on the inside of your function, it's going to flip it over the y-axis. Okay, now I'll show you what that looks like. Okay, so the first one here, you see we have an outside. So again, the parent graph is this. And we're going to flip it over the x-axis because, again, it's on the negative is on the outside of my function. So I'll do the reflection in blue. So it's just going to flip over just like that. That's bad. Okay, I want to do one more, or I'll try to do 2 more real fast. Again, here we've got a negative inside, so it's going to actually flip over the y. But here's a parent graph. The weird thing about this one, guys, is that when you flip it over the y-axis, you see that it's actually the same on both sides. So we can just draw this again. Oops. Last one real fast. Okay, you see y equals a negative x. Again, the parent is going to look like that. Okay, and I'm going to flip it over. I'll do it in red real fast. It's going to look just like that. See you guys next time.